Welcome to our second video. This one's about electron configuration. There are two videos to this concept. They are both called electron configuration. This one, though, is video 2, and the other is 2.5. You'll learn about the brief concepts and sort of how to do the electron configuration. Then the next video will show you really going into the formulas and examples. So, as we finished talking about in our first video, our current model is the quantum mechanical model. And this basically states that orbitals or electrons will be in orbitals, which are high regions of probability. And ultimately, our goal with this concept is to figure out where exactly the electrons will be placed. This allows us to predict the actual shapes the molecules will take, and even determine the charges the atoms will form. You can even use this to predict the charges that even transition metals will take. But as a reminder, protons, neutrons are in the middle, electrons are on the outside. We are going to figure out where exactly these electrons, or at least get a pretty good idea of where they can be found. Orbitals are found in different energy levels, and meaning distance away sort of from the nucleus. So they can sort of be, one of the orbital shapes is kind of like a circle. So you can find orbitals of that shape, or that, or that, or that, kind of keep getting bigger and bigger shapes. However, though, there are 4 different types of shapes. They are S shapes, P shapes, D, and F. And there are, those are 4 shapes. Each of those shapes, however, only comes a certain amount per level. For example, every level, sorry, this is not there. Come on. I don't know why it doesn't want to write, so I'll try and figure it out. For example, there we go. Every energy level, you can find 1 s orbital and 2 electrons. You'll learn soon that 2 electrons can go in every orbital. But on every level, you can have 1 s orbital, 3 p's, 5 d's, and 7 f's, for a total of 2 electrons in the s orbitals, 6 in the p, 10 in the d, and 14 in the f blocks. This will make more sense as we start using it. But try to remember that S goes with 2, P in 6, D 10, F 14. So the following chart also indicates what orbitals are allowed per energy level. For example, on energy level 1, which is our lowest, our smallest, the area right next to the nucleus, you can only find s orbitals. Example up here, we only write s. This chart you'll be using in a bit, so try not to completely forget it. But on level 2, you can have S and P. Level 3, you can have S, P, and D. And level 4 onwards, you can actually do all the way to F. 6 also would have F, despite what this chart says. We just don't actually have any elements in the 6F block, so we just didn't write it in that chart. But again, S goes with 2, P is 6, D is 10, F is 14. And on energy level 1 is S, then we have SP, SPD, SPDF, all the way onwards. So, how many electrons are allowed in energy level 3? Well, hopefully remember that in energy level 3, we can have S, P, and D orbitals. And hopefully remember that we can have 2 electrons in S, 6 in P, and 10 in D. So if we were to completely fill those orbitals, that would be a maximum of 18 electrons, which means that is how many electrons energy level 3 can hold. And they will be found in S, P, and D blocks. So that's kind of a introduction to orbitals. Feel free, as always, to rewatch any of these slides as you wish. Well, in your case, video, so scroll back a bit. But let's move on. So finally, there are some rules and principles that will help us determine electron configuration. The first is the off-bow principle. This states that electrons can occupy orbitals with the lowest energy first. So they go to whatever is easiest for them. This chart represents orbitals and their energy level. So the one that requires the lowest energy is 1s. Then we have our 2s. This means the s orbital on the first energy level. But we have 2s and then 2p, which kind of makes sense. You're kind of just going down the chart. 3s, 3p, and you would normally assume 3d. But this is where it gets a little weird, because notice 4s actually is less energy than the 3d. So it kind of goes in this weird funky pattern thing, but that all comes down to whichever orbital is the lowest energy. To help you remember this, we have this chart again, which again, I'm going to actually write 6F this time. Well, I'm going to try and write 6F. There we go. This chart is one of the main things that you need for electron configuration. Try to memorize it. Try to learn how to draw it. Yes, the arrows do matter something. Let me show you, though, how to draw this. It's very simple. You do 1S, 2S, 3S, 4S, 5S, 6S, and I actually normally go to 7S. 2P, 3P, 4P, 5P, 6P, 7P. Hopefully you notice that we don't have a P in the ones, because at energy level 1 you can only have an S. Energy level 2 doesn't have a D because you can only have S and P. So that means at 3 we start Ds. And then 4 we start Fs. And now we draw our arrows. The arrows typically kind of confuse people, but hopefully this will kind of make sense. First one goes through 1S, second goes through 2S, then 2P to 3S, and so on and so forth. Now, I'm honestly, well, I'm not doing anything, but I'm going to recommend that you actually pause this video, draw it on your notes, and make sure that you get the same chart. I'm not joking when I say this is really all you need for electron configuration, but that also means that if you forget it, you're going to forget almost all of electron configuration. So pause, take some time to get this, and yeah. All right, I'm going to assume that you've paused. If not, rewind, pause, etc. I'm going to show you how to read this. The first one that electrons that these arrows go through, actually I'm going to erase my chart. We're just going to run off the other chart. I wish I had this like clear all button. Oh well. This is also another good time for you to try and draw it while I sit here and erase everything. It's probably, I'm using an app called Explain Everything. It's a pretty good app. Allows me to do all this with my iPad. But again, I don't have a clear all button currently. Why are you not erasing? That's weird. Okay. So, first one is 1S. Then we have 2S. Then 2P and 3S. Here's where it gets a little different. So 1S, 2S, 2P, 3S, 3P, and a lot of people would think, oh, just go to 3D. But notice that's because they're reading it like this, when you actually should be reading it like this. Hopefully you see the difference. Oh, sorry. Actually should be an arrow there. So 3S goes to 3P, and then to 4S. We then go 3D, 4P. And I'm going to pause a bit. Why don't you try and actually figure out the rest of this? Take a little bit, write down the rest of these numbers, that way you can check it. Alright, I'm going to assume that you've actually taken time to pause and finish the chart. So, hopefully, let's see how well you did. If, however, you're just, kind of sitting there thinking, oh, I'm not going to pause the video, Mr. Booth's not going to know. That's true. Congratulations, you've told yourself you don't want to learn. So rewind, go back to where I say pause, try it yourself. Make sure you can do this, because you're not going to have me on your test. You need to do this yourself. And that's the order, though, that we're going to fill electrons in. Yeah, that'll come in handy very much in our next video. But again, make sure you can do the chart and actually write it out in the order it says. Okay. We have another principle. It says the Pauli exclusion principle. Basically states that any orbital can have 2 electrons at a time. So, in addition, if they are at the same time, if there are 2, they have to be spinning in opposite directions. So notice each of these line represents an orbital. So these 3 represent all 3 p orbitals in the second energy level. Each line only holds 2. But notice this is wrong because we have 2 going upwards. We actually should have 1 going up and 1 going down, kind of spinning in opposite directions. A way to help you remember this is Pauli. You know, the L you can think of as an up arrow and the I as a down arrow. So, if that helps, yay. Finally, Hund's rule. States that when we're filling multiple orbitals at the same energy level and shape, like our 2p orbitals, that we need to have all the electrons spinning in the same direction, at least as much as possible. So basically everything will have an up arrow before any has a down. So that's why we have up, up, and up for our 3 electrons, not up, down, up. Because you should actually have something over here. This down should go right here to go up. That's Hund's rule. Alright, let's practice Hund's rule real quick. If I have 5 electrons to place in 3 orbitals of the same energy level and shape, how would I draw their orbital diagram? I'm going to pause and let you try it for a bit. That way you get practice. Please remember you learn best by practicing. So don't just sit there and listen. Alright, I'm going to assume that you have done this, or at least pause the video. So, 3 orbitals means line, line, line. 5 electrons means an up. We still have unfilled orbitals, so another one gets an up and another up. They are now all filled, so I start putting down arrows. So I put a down and a down. There you go. That's how you do orbital diagrams. Please remember to always do ups before downs, even if it looks like you don't need to. It's a really good habit to get in. Thanks for watching the video. Feel free to watch the next one. That explains actually running through doing electron configuration.